Another example of PDA, okay, is to draw a PDA diagram, okay, which to recognize, okay, this language, okay, a power of I, b power of j, c power of k, where I equal to j or, okay, I equal to k. So we need to make sure that, okay, a, okay, number of A must be equal number of B, okay, because I equal J. So A power of I, B power of J. So number of A must be similar to number of C. Or, okay, we need to make sure that, okay, number of A must be equal number of C, because I equal K. So A power of I, C power of K. So in this case, okay, there are two situations that we need to make sure that, okay, first is A must be equal B, okay, number of A must be equal number of B, or, okay, number of A must be equal number of C. Okay, in this example, okay, the main alphabet is A. Okay, once we read alphabet A, we need to push symbol into stack. Okay, we need to count how many A's, okay, and then we need to count how many B's or how many C's, so that number of A must be equal number of B or number of C. Okay, for the first case, okay, we try to solve, okay, a and b first. Okay, number of A must be equal number of B. So once we read alphabet A, okay, we push symbol, okay, into stack, and then after that we read alphabet B, and then we will pop symbol from stack. Okay, second case is A and C. Okay, once we read alphabet A, we push symbol into stack, and then once we read alphabet C, we will pop symbol from stack. Okay, for the case 1, okay, for the case 1, we uh, need to make sure that number of A must be similar number of B. Okay, okay, for the first state here, okay, Q1, okay, we set up our stack, okay, where we push, okay, $sign symbol, okay, into the bottom of stack, okay, and then, okay, next state, okay, Q2, okay, we start read alphabet A. We read alphabet A, and then we push symbol capital A into stack. Okay, so the first one, the first case, okay, we push $sign, and then once we read alphabet A, we push capital letter A into stack. Okay, okay, so this is a loop at Q2. Okay, so for example, okay, if 2A's, okay, if we read 2A's, so we push 2 capital A, okay, into stack. Okay, and then this, okay, for the first case, we need to make sure we need to count how many A, okay, so that we also can count how many B's. Okay, number of A must be similar, equal number of B. So after we push symbol A, capital A into stack, okay, and then we read B, okay. Once we read alphabet B, we pop, capital A from stack. So we start pop, Okay, we start pop capital A from stack. Okay, until um, okay we found that uh, dollar sign. Okay, until we found that symbol dollar sign in stack, and then we will go to final state. Okay, final state. Okay, at final state, okay, actually this one already we already accept, okay, this language. Okay, at this stage, okay, we still can read another alphabet C, but in this state, okay, we do not count how many C's, because C is a independent. Okay, number of C is independent, not depend on A, not depend on B. For the second case, okay, we need to make sure that number of A must be similar number of C, but between A and C, okay, there is a alphabet B. So alphabet B is a independent alphabet. Okay, B not depend on A or C. So B is a independent. So no need to push or pop. So we do not so this alphabet B is not will not no need to push or no need to pop stack. Okay, so we only consider A and C, okay, with where this A and C will interact with tag. Okay, once we read alphabet A, okay, we push symbol, okay, we push symbol capital A into stack. Okay, so next we read B. We not do any push or pop, okay, in stack. And then next we read alphabet C. Once we read alphabet C, we will pop capital A from stack. So in this diagram, okay, we read A and then we push capital A into stack. And then next, okay, we read alphabet B, but we do not push or pop any alphabet into or from stack. Okay, because B is a independent alphabet. And then next, okay, after we read we read alphabet B, we start read alphabet C. Once we read first alphabet C, okay, we pop, okay, capital A from stack, okay, until there is no more C, okay, there is no more C, or we finish read uh, string, okay, and then we at the same time we found that in stack there is only dollar sign symbol, and then we will go to accept state. Okay, non-deterministic or non-determinism in PDA. Okay, the formal definition of PDA allow non-determinism. Okay, PDA, okay, can be deterministic or can be non-deterministic. Okay, a PDA is called non-deterministic, okay, if there exists at least two possible transition from a particular situation, okay. For example, from current state Q with same input symbol and stack symbol X, so there is at least two possible transition. Okay, for example, okay, from Q naught, okay, from Q naught, okay, okay, from Q naught, okay, uh, with a same symbol, okay, same symbol, read same symbol, and then also same symbol in stack, okay, okay. So there is, okay, there are two situations from Q naught to another state, okay, with a same alphabet and same symbol in stack. Okay, this is a non-deterministic. Okay, this is example, okay, of deterministic PDA. Okay, so we need to draw PDA diagram that can recognize, okay, this language, okay, where W CW reverse, okay, okay, where W, okay, contain alphabet 0 or 1. Okay, this is a deterministic PDA because, okay, in this combination of string W and W reverse, okay, there is a symbol C, okay, that our diagram can know, okay, which the left string and the right string. The left one, okay, is a W, and then the right string is a W reverse. So alphabet C, okay, is in the middle of the whole string. Okay, for example, W. If W is 110, okay, and then W reverse must be 011. Okay, W and W reverse, and then between this, okay, W and W reverse, there is a symbol C. Okay, so easy to recognize, okay, between W and W reverse. Okay, the left side and the right side, okay, there is the middle of the string is alphabet C. Okay, how we draw a PDA diagram? Okay, first we set up our stack, okay, and then, okay, we start read alphabet. Okay, for example, okay, we read 110. Okay, 110. So we read alphabet 1, okay, and then push we push 1 into stack. Okay, in this case, okay, okay, we read 1, we push 1, we read another 1, we push 1, and then last we read 0. Okay, we push 0. Okay, and then next alphabet that we read is C. Okay, so we read C. Okay, so we will go to Q2. Okay, at Q2, okay, if we read 0, we will pop 0. If we read 1, we pop 1. So we read 0, we read first 0, we will pop 0. We read 1, we pop 1. We read last 1, we pop 1. So and the last, at last, in stack, okay, only $sign, okay, there is no more alphabet, and then at the top of stack is a $sign, okay, and then we will go to accept state.